Okay, let's start the lesson. Hey, welcome to lesson 10.4, angles inside and outside of circles. Today you're going to be learning two interesting theorems involving angles that are both, well, I said it, inside and outside of circles. All right, our first theorem is the intersecting chord angle theorem. And remember, you'll probably have a feeling that this has to do with chords. And remember that chords are just lines inside of circles with its endpoints on the circumference, okay? So if you have two intersecting chords like we do here, there's a theorem that we can use. The theorem is this: the measure of an angle formed by two chords that intersect inside a circle is the average of the measures of the intersected arcs. And what does that mean? If I wanted to find this inside angle right here, right? These two chords intersect and create these two angles. If I want to find either of these angles, all I have to do is find the average of my two intercepted arcs, which in this case would be AD and BC. So here's your basic formula. The angle on the inside, right? The angle formed by the arcs. The angle okay, be cool. The angle formed by the two chords, okay, is equal to the intercepted arc 1 plus the intercepted arc 2 divided by 2. So you're taking the average of the two. That's it. This is going to be your formula that we're going to be going back to today for this theorem. So just keep it in your pocket because it's going to help you out a lot. So our first question of the day is we want to find the value of angle AED. And let's first figure out where angle AED is. That would be here, angle AED. That is an angle formed by the intersection of two chords, right? I have my chord AC, I have my chord DB, and it makes this angle right here. If we want to figure out what this is, my angle, which we'll say is X, I have to take the average of my two intercepted arcs, which would be AD and BC. So to do this, let's just plug into our formula, okay? So my angle, which is X, just plugging X for my angle, is equal to 100, which is my first arc, plus 50, which is my second arc. To solve this, I just get X is equal to 100 plus 50. Well, 100 plus 50 is 150 divided by 2. And I'm going to solve this guy out, and I get 75 degrees. All right, and that's it. So angle AEBD is equal to 75 degrees. Oh, that's a weird looking 5. 75 degrees. And by the way, these are vertical angles, so I could do that for either one of these. This angle is also 75 because these are vertical. All right, so both angles are both 75, but I'm only looking for AD, which is 75. So it's that simple. I just took the average of the two arcs. Let's try this again, okay? But this time it's a little different. I want to find the value of GH, arc GH. And arc GH is right here. All right, my arc GH. So let's put an X there because that's what I'm looking for. And if I'm arc GH, I can still just plug into the same formula because in this case, I still know an angle, which is 80, okay? And I know one of the arcs, which is 95. And I could just plug each one of these three things in my formula and just solve for X, which is GH. Let's try it. So my angle, which goes here, is 80 degrees, right? That's on the inside. My outside arc, one of them is 95. And my other arc is X. So I just added my two arcs, divided by 2, which equals my angle. And I'm trying to solve for X here. So now that I have everything plugged in, how do I solve this? Well, you might remember, and this is from lesson 6.5, I want to get rid of that 2. And to do that, I'm going to multiply both sides by 2. Right? That gets rid of that on this side. These cancel now. Now I get 2 times 80, which is 160, is equal to 95 plus X. I'm going to subtract 95 from both sides. All right. And I get X is equal to 65 degrees. X is equal to 65 degrees, which happens to be GH. So GH is just 65 degrees. Now, I don't like to just say, like, we got the answer, let's move on. Let's actually check our work. Let's do a quick check here to see if that even makes sense, right? 80 should be equal to my two arcs, which is my two arcs. So 80 degrees, which is my angle, should be equal to my two arcs, which is 95 and 65 divided by 2. Let's check that out. Well, 80 is equal to 160 divided by 2, and 80 is equal to 80. So that did work out. If x is 65 and that's 95, everything works. Well done! Okay, so that was one theorem. This is going to be our second theorem for today. And this is the outside angle theorem. And this has only to do with angles that are outside the circle, such as angle F. Alright? The previous ones you've learned is inscribed angles, which are on the inside, and the chord theorem. What we're looking at now is outside angle theorem. The outside angle theorem is this. The measure of an angle at a point outside the circle is half the difference of the measures of the intercepted arc. So half the difference is basically saying if I take the two arcs, the two intercepted arcs, which in this case would be this guy right here and this guy right here. If I took the difference of these two arcs and took half of that or divided by 2, that should give me my outside angle. Alright, so the big arc minus the small arc, this would be the big one, this would be my small arc. Subtract those, divide it by 2, and that will tell me what my angle is. Okay? Well, once again, all we have to do is use this formula at the appropriate time and we should be good. So let's try our first example over here. This example wants us to find the value of B, angle B, which is right over here. And this, of course, is outside the circle. So we'll use the outside circle theorem. Well, we know that the outside circle theorem states that the angle is equal to the big arc minus the small arc divided by 2. Since we don't know our angle, let's put an x here. And we'll just plug into our formula. So x, which is our angle, is equal to the big arc, which is 110, minus the small arc, which is 50, divided by 2. Well, let's simplify that. 110 minus 50 is 60 degrees divided by 2. Okay? And if we divide that, we get 30 degrees. All right. So we know that angle B is equal to 30 degrees. Let's fill that in over here. Easy. Just plug it in. Well, let's try our second problem now. We want to find the value of arc GI. Okay, arc GI, which happens to be our smaller arc. Since we don't know that, let's put an x there, and let's just plug into our formula now. We know that the angle, which is 40, is equal to the bigger arc, which is 200. That's a big arc. Ooh. Oh no, what's happening? Okay, it's all good. It's all okay. We're all fine. Anyway, so our angle is equal to the big arc, which we know, minus the small arc, which we don't, so we'll just put an x there. And now we'll just solve this equation. So we'll multiply both sides by 2 so we can cancel those out. And we get 80 is equal to 200 minus x. To solve here, we're going to subtract 200 from both sides. And look, that's a little crazy, right? We get negative 120, but that also equals negative x, which comes down. Since they're both negative, you can multiply both sides by negative 1 or just change the signs and you get x is equal to 120. Put it in right there. Sweet. So GI is equal to 120 degrees. And once again, it's good to check your work. Is 200 minus 120 divided by 2 equal 40? Well, 200 minus 120 is 80. Divided by 2 is 40. So yeah, we did that correctly. Now this is our final one. What we have here is two tangents. We have JK as tangent and KL as tangent. Now you might remember these are congruent, but that has nothing to do with anything. That's just the Princess Hat theorem. That doesn't help us at all. And we want to find the value of K. That is our angle. Okay, so let's put an X there. Now you might be looking here. We don't know the angle. We know the big arc, But we also don't know the small arc. So how are we going to supposed to solve this, right? We have two unknown values. Well, the truth is we actually only have one unknown value. Take a look here. Since we know that these are just 2 points right here, right? These are both tangent. We know this whole big arc is 250 degrees, all right? And the way we could find this small arc right here, right, is just taking 360, which is the whole circle, and subtracting 250, and that gives us 110 degrees. So this is 110 degrees, because these two arcs make the whole circle. Now if you look up here, that doesn't always work, right? Now in this case, if I subtracted this arc over here from this arc, there would still be a missing piece. This only works when you have two tangent lines, okay? That should be clear to you. It only works if you have two tangent lines, where you have two segments of the circle separated. One's 250, one's 110, and that equals the whole circle. Well, now we could solve this problem. So our angle, which is x, is equal to 250 minus 110. We subtract over here, we get x is equal to 140 over 2, and we get x is equal to 70. So angle K is equal to 70 degrees. We'll just fill that in over here. All right, it looks like we're on a roll here. Now we got two challenge problems here, and I'm just going to walk you through them. All right. In the company diagram, AD and BC are chords on circle O, and they intersect at E. The measure of AB is 70 degrees, so let's write that in. AB is 70 degrees. And the measure of arc CD is 90 degrees. What is the measure of angle AEC? And AEC is this angle right here, right? AEC. Now here's the problem. I can't just add these and get this angle, right? Because angle AC is not my intercepted arc. I could either find this angle or this angle. So let's start with that, okay? Because that's all I can do right here. I can't find this angle directly because I don't know what it is. And I don't know what these two arcs are. So what I'm going to do, I'm going to do the following. Hold on, sorry. I'm going to do the following, which is this. I'm going to find out what this angle is here first, okay? This guy missing right here. I want to find out what this angle is. And I can do that by saying the angle is equal to my two arcs added together and divided by 2. Because these are chords, I'm using the chord theorem. When I do that, I get 160 divided by 2, and I get x is equal to 80 degrees. Now that is just the first part of the problem. 80 degrees. How am I going to find this second angle right here, the one I'm actually looking for? Well, if you've really been paying attention this year, you should know that this is a straight line. These two angles make a straight line, right? Look. Oh, there it is. In fact, let me get rid of all this other jazz around here. All right. So I can be clear about it. Got a little cluttered there, guys. We found out that this was 80 degrees. And look, this is a straight line right here. And this is my two angles. They're supplementary. So to find this missing angle, all I have to do is 180 minus 80. And I get 100 degrees. And now I have the answer to my question. So the measure of angle AEC is equal to 100. So I just want you to take from this, sometimes you can't go directly at what you're trying to solve, but you can solve what you know, okay? And that's a big part of being good at math. Sometimes you might be a little perplexed or confused about what you need to do. The key to doing math well is just doing what you can do. And going from there, that's always a good starting point. All right. Second part of this, all right? In circle E, AC is a secant line and DC is a tangent line. Line segment AB is the diameter, okay, of circle E. If BD is 30 degrees, find the measure of angle C, which is on the outside. And we're going to say that's X. Well, how the hell are we going to do that? Once again, we have this whole missing arc over here. We know our small arc is 30. We know we're missing this angle. but we don't have the big arc, which we need to be able to solve this problem. Well, once again, this can be solved if you look at some very important lines. Words. AB is the diameter, right? So this goes right through the middle. So what's that tell me about this whole arc over here? What's my whole arc going to be? This whole arc is going to be 180 degrees. That's why they put the word diameter there, to know that that's 180. So if I want to find this other part of the arc that goes from here to here, all I have to do is 180 minus 30, and that gives me 150 degrees. Well, now I have my small arc and my big arc, and I can do my equation. So the angle is equal to 150 minus 30. I'm subtracting now because this angle is on the outside, divided by 2. Oh, x is equal to 150 minus 30 is 120 divided by 2. X is equal to 60. So the measure of angle C is 60 degrees. Genius! All right, guys. Oh, it just went over 16 minutes.